She's an assistant professor of public policy and the environment at UNC Chapel Hill and the founder-director of the Data-Driven Enviro Lab. Please welcome to the stage, Angel Hugh.
Thank you, Wade. I feel like I should be playing hockey and not talking to you about climate change. But it's hot, y'all. Am I right? Today, I want to talk to you about our research that looks at the intersection of urbanization and climate change. We're living right now in the urban century. More than half of the global population is currently living in cities, and this number is expected to increase to 70% by 2050. Here in the Raleigh area, we can witness this transformation of urban growth happen from the 1980s up until today. We can see the land cover being transformed from green areas to bright urban areas. Globally, we're also seeing the same patterns all across the planet. These bright lights that you're seeing are coming from cities. This is measuring from space economic activity. Cities produce more than 80% of global GDP, and most of this anticipated future growth is happening in China and India. Following this growth in urban population in cities and GDP is also these negative trends, these Earth system trends, an acceleration of pollution, carbon dioxide, and other greenhouse gas warming pollutants like methane, nitrous oxide, also an acceleration of ocean acidification, and also tropical forest loss. Here in the Raleigh area, I have a satellite image of Raleigh here on the left. You can see some of this transformation happening in areas that are white, following roadways, where buildings, residential areas are some of the hottest areas that you can see on this map here on the right in red. Cooler areas are lighter in blue and in yellow. Why is this happening? Well, this is due to what's known as the urban heat island effect, and it measures the temperature difference between an urban area and its rural surrounding. And so you can see in this red squiggly line here that areas that are rural or suburban where they have more tree cover and more grass are cooler during the late afternoon. And in commercial and city areas downtown, they tend to be much hotter. Why is this phenomenon happening? Well, think about asphalt and concrete. In urban areas and downtown districts, they have a tendency to retain solar energy and heat. They re-radiate that out to make urban areas much hotter. When we convert natural landscapes and forests into built environments, we also make them less impervious, or we make them more impervious rather. And so they can't absorb rainwater like a natural landscape can. And so as a result, the urban heat island can make cities 3 to 10 degrees on average hotter. That's Celsius. But we also know that cities are not created equally. And these are amazing photos from photographer Johnny Miller's Unequal Scenes project. This is actually New York City. And you can see here in this scene that much wealthier Upper West Side residents have access to Central Park, more than 800 acres of green space. And we're seeing these images of inequality all across the world. In Mexico City, we can see in this one image a much less wealthy neighborhood characterized by this informal soccer pitch juxtaposed next to this much wealthier neighborhood where you can see these really nice sporting facilities. In Johannesburg, South Africa, it's the same picture, an informal settlement right next to a golf course. In Raleigh as well, we're seeing the same types of inequality, and that inequality is leading to different exposure in urban heat. Here, this is a map that we produced of Raleigh and its various neighborhoods. You can see the hottest areas in red coincide with those areas with fewer tree cover, and that also happens to intersect with the neighborhoods that are the least wealthy in light white or blue on the right. So we started to ask the question, is this an isolated incident? Is this just happening in one city, in large cities like Chicago or New York City or Mexico City and Johannesburg? But what our research has found using satellite data is that this is not an isolated problem. In 97% of cities across the United States, signified by these triangles, we're finding that communities of color and people who are living below the poverty line are exposed to higher levels of heat than their wealthier and their white counterparts. On average, we're finding a full degree Celsius, that's almost 2 degrees Fahrenheit, higher urban heat exposure than their counterparts. And so this suggests that there's something more widespread going on, some systemic form of climate racism or environmental injustice that's happening all across America. Some of this may be due to historic racist redlining policies that have prevented minority communities from accessing more desirable parts of cities. This is a map of Durham and the redline districts that were graded in lower grades of D or F as compared to non-redline areas that happen to be cooler and shadier. So what can we do about this problem and these disparities? Well, as a researcher and a data scientist, I'm going to say we need to get more data. And luckily, last summer, the County of Durham, the City of Raleigh partnered with scientists to engage citizens to go out and map urban heat islands within Durham and Raleigh. The problem with our current measurements of urban heat and temperature is that if you check your phone, if you go to the weather station, it's normally coming from one place, and that's normally from the airport. Who lives at the airport? I don't know, maybe somebody does. I certainly don't live at the airport. I would imagine that most of us don't. And so that's not representative of all the different intra-urban differences that we experience on a daily basis. I'm sure all of us have walked around in a downtown area, outside in our neighborhoods, and we notice a huge difference when we walk under shade. And so that's exactly what this campaign was doing. And now the City of Raleigh is taking that data, and they've invested $77,000 to try to mitigate these differences. So they're looking at where they can plant more trees, increase access to green space, also coat roadways with titanium oxide to make them cooler and more reflective. This data is absolutely critical to solving this problem. Just as a last example, we replicated this same exercise in Chapel Hill last summer on an extremely hot day in August. And on that day, we sent 40 volunteers out with these handheld Pocket Lab sensors that you can see in blue to map 5 of Chapel Hill's neighborhoods that the town identified were particularly vulnerable to urban heat. What we found was really surprising. So when I checked my phone that day, it said the temperature in Chapel Hill was 94 degrees. In some places, we measured temperatures as high as 108 degrees Fahrenheit on that day. And what was even more shocking, I don't know if you can see the box, the little plots in the middle, Meadowmont neighborhood, we didn't find that much of a difference between afternoon temperatures and evening temperatures. That's incredibly worrying because that's the time when our bodies are supposed to recover from high heat exposure in the day. So this is just a start, and I hope that you'll get excited to participate in our next campaign. So thank you so much. And this is a picture of a squirrel on Twitter getting some relief in a bowl of ice on these incredibly hot days. So thank you.
That's right, protect the squirrels, y'all. All right, Q&A time about urban heat island sustainability. All right, I'm going to go back here first. Front and left.
Hey, first of all, I'm a UNC grad, so go Heels.
Great.
Second of all, I saw on your map of the U.S., you said 97%.
Yes.
It was worse for lower income and minority areas. What are the
Lower income and minorities. So some of those lower income could also be white populations as well.
Okay. What were the ones that were not? I couldn't find any of the circle ones. And of those areas, are there any lessons in governance that the other areas could learn from?
Yeah, so that's a really great question. There were only 6 cities where we didn't see this disproportionate exposure for minority and below poverty communities. And actually in those cities, they just had a larger proportion of white, non-Hispanic white communities as compared to communities of color. So that was really the reason. They're just not very diverse cities. And so unfortunately, there's not really, I think, a policy lesson there unless you just want to keep your cities not diverse, which I don't think is a goal. But yeah, that's a great question. And I mean, I would say that there are some cities that are doing interesting things. I think this Raleigh example was fantastic. So we had someone from the Office of Sustainability in Raleigh speak at a webinar last week, and so that's available on our website, datadrivenlab.org, to hear exactly about how they're using the data. I mean, I think it's so fascinating. As a researcher and a scientist, we create these data sets all the time. We hope that policymakers will use them, and without this kind of data, they wouldn't know, well, what neighborhoods are hotter than others, and why? Is it because of tree cover? And one of the things that they noticed on what they pointed out on the map is one of the highways is one of the hottest areas, and they actually don't have control over it because it's a state-owned highway. So things like that, these lessons are really fascinating, and without that really granular data, they wouldn't be able to identify, oh, this area is particularly hot. So I think what City of Raleigh is doing is a great example. City of Phoenix, they actually have a urban heat mitigation office, and they actually have metrics to increase shade and tree cover in their city. So I think that that's also, from a data-driven perspective, another good lesson that we can take.
All right, next question coming up here from the gentleman in the yellow shirt, front and center.
As far as solutions, you mentioned the titanium dioxide spray.
Yeah.
That sounds like a very quick fix. I don't know if it's expensive or not, but can you speak to any other things that are kind of quick? Because planting trees takes a little while before they're big enough to make a substantial difference.
Yeah.
Maybe also green roofs would be something that.
Yeah, exactly. So green roofs, also in New York City, when Mike Bloomberg was the mayor, they had this cool roofs campaign. So they had a target to increase the number of cool roofs in the city of New York. And so they were actually coating the rooftops of many buildings with a very reflective white coating. I would say that that's like one of the biggest bangs for the buck because white has a much higher albedo, so the surface reflectance. So it's actually radiating and reflecting that heat back into space. So I think albedo, will be say in the climate science, albedo management is probably the number one thing. Yeah, because you're right, that tree planting takes a while. Yeah, and planning, urban spatial planning, making sure that buildings are configured in a way to allow for urban wind cannons to cool places and designing parks that also are plentiful with tree cover. So yeah, I mean, I would say, yeah, this albedo management. So that's one of the reasons why. And I can't remember exactly the number she said in the webinar last week. It was either a 40% reduction in heat or 400%. I know that's a big range, but it was like, I remember thinking, wow, but it was something like that where they were able to measure using this high resolution data, the difference before and after.
Other questions? Let's see, we've got one right here front and center.
When it comes to people moving to more urban areas, are you seeing any issues when it comes to light pollution and how that could affect maybe minority communities more or even like wildlife also?
Yeah, no, that's a really good point. Yeah, light pollution is a huge issue, I think particularly for wildlife. I mean, one of I think the interesting things about this research is that there's actually been a lot of science and a lot of research done looking at just environmental pollution, disproportionate environmental pollution exposure for minority communities that often have to live in less desirable parts of cities. So next to landfills or next to busy highways or next to toxic waste facilities. And so there's been a lot of research that has shown that minority communities are disproportionately exposed to air pollution and other toxic chemicals. But I think one thing that we did that was different was actually establishing these patterns for heat. But yeah, I mean, I think light pollution is certainly a concern. And during COVID, when people were not commuting and we were emitting fewer emissions, we did see a recovery in a lot of species, particularly in urban areas.
Our last question will be front left from your perspective over here.
Are there any private or public incentives to build green spaces just to make those areas around it cooler?
Yes, that's a great question. I'm not sure if I just recently moved back here. I'm originally from South Carolina. That's why I felt okay appropriating y'all in the title because I'm actually I was born and raised in South Carolina. I went to undergrad at Wake Forest, so I felt okay. But I don't know within this area yet because I'm still so new to it. But I used to live in Singapore and I lived there for 5 years. And they absolutely do have laws, zoning laws and building laws where if you displace any type of greenery, you have to actually rebuild it in your project. And so I think that that's one example of a really innovative policy. And so in Singapore, it's incredibly dense. It's one of the densest and most highly concentrated populations in the world. And they have these incredible vertical gardens. And so you can see these pictures of buildings where they've got greenery that's hanging off of buildings. They've got sky gardens. And I think that's one example of where there's direct regulation. And I'm sure that there are some zoning laws, but there's just so much diversity in the US. But yeah, I think Singapore is a great example.
All right, give it up for Angel Hsu.